Hello everyone, I am Ashwin Chauhan. Welcome you to the next part of data science series. Today we are going to discuss dimension reduction, and the topic which we cover in this video are demonstrate how you will identify multicollinearity Python using Python. Demonstrate how you will apply principal component analysis using Python. So let's begin to start with definition of multicollinearity. So what is it? Multicollinearity arises when independent variables in a dataset are highly correlated. This can lead to unstable and unreliable regression model detection method. We will explore common techniques for identifying multicollinearity in Python, including correlation matrices, variance, inflation vectors, VIF, and condition number. Addressing multicollinearity techniques and strategies. Variable removal. Removing one of the correlation variable can help alleviate and multicollinearity but may lead to loss information. Data transformation. Transforming variable using technique like standardization or centering can reduce the correlation between them. Principal component analysis (PC), a powerful dimensionality reduction technique that transforms correlation variable into uncorrelated principal component, simplifying data structure. Now let's see the program of multicollinearity. So here, this is the program of correlation matrix where we import our libraries of pandas and matplotlib to plotting a graph. Here we consider a simple data and passes it into data frame and plotting the graph of this data. So this is the output of above program. Now let's see the program of VIF, calculating the VIF for each feature. So here we will input necessary libraries like pandas and sets model and variance inflation factor and add constant and consider a data in consider a simple data in the variable called data and pass this data into a data frame. Now so by applying a method the output is generated. So here it is the output of the above program where VIF is indicated is calculated. Now let's discuss introduction to principal component analysis (PCA). Data standardization. Transform variable to have zero mean and unit variance, ensuring equal contribution of each variable to PCA. Converging matrices calculation. Calculate the converging matrices to understand the relationship and dependency between variable. Eigenvalue decomposition. Decompose the convariance matrix into a eigenvalue, eigenvectors, and eigenvalues, which represent the direction of maximum variation and amount of variation explained. Applying PCA step-by-step implementation in Python. So by these three methods, we can apply PCA in Python. Data loading and preparation. Load the data, select relevant feature, and perform necessary preprocessing. PCA implement. Instantiate a PCA object, set the desired number of components, and fit the model to a standardized data. Data transformation. Apply the fitted PCA model to transport the original data into reduced dimension space. So now let's check the program of PCA. Here, this is the program of PCA to generate a PCA model. Now, here we import a necessary libraries, load the data into a data frame, and apply a algorithm to generate a program. So here here it is the output of the above program. Here PCA dimensionality reduction is making for us. So by putting a show function, we draw a graph in the using a matplotlib. Now let's move to our topic called interpreting BCA result in which eigenvectors and eigenvalues. Eigenvector represent direction of maximum variable in data, highlighting the relationship between original variables with each component. Eigenvalues indicate the amount of variance captured by each component, allowing you to prioritize component based on their explanatory power. Component loading. Examine the confidence of each variable in a eigenvectors to understand the contribute of original variable to each component. Dimensity reduction with PCA. Selecting the optimal number of component. Screen plot analysis. Visualize the eigenvalues in descending order to identify the elbow point where the rate of variance explained started to flatten. Cumulative explained variance. Cumulate the cumulative explained variance to determine the number of components needed to capture a desired percentage of a total variance. Domain expertise. Consider the context of the data and the goal of an analysis when choosing the optimal number of components. Conclusion and takeaway of dimension reduction. Multicollinearity poses a significant challenge for statistical and modeling. PCA provide a robust solution for dimensionality reduction, transforming correlation variable into an uncorrelated principal component. By understanding the principle and implementing of PCA, you can give valuable insight from complex dataset and build a more reliable model. So this is all about the dimensional reduction. If you have any doubt, then comment in the comment box. Thank you for watching the video.